Welcome everyone to our asynchronous class. Today is the senior SAT day, so what we're going to do is we're going to kind of try and close out our previous lesson. And what I'll do is I'll kind of cover what we would have covered if we'd met in person on Friday. It's just standard deviation and mean is what we'll talk about on Friday. We've kind of talked a little bit about it, but I'll kind of give you some further details about it on Friday. But here's what I need you to focus on today. If you go into our Unit 1 in our Schoology Unit 1 Exploring One Variable Data folder, I've added a new folder called Day 3 Part 2, which is the asynchronous one. And inside there are a couple things for you. The first thing that I want you to look at is I've actually given you kind of a good summary of dot plots and histograms. If you actually go ahead and look at it, I'll bring it up on my document camera so you can see it. It gives you a good review of what a dot plot is. I'm not going to read that to you. I'm going to let you kind of look that over and see if you have any questions from it. That's what we spent most of the class talking about last time was our dot plots. I want to talk about histograms. So again, we talked dot plots, now histograms. What the deal is with histograms is basically using bars to represent counts. That's called a frequency. Or using bars to represent relative frequencies, which would be percentages. So if I counted the states, just the raw number of states, that's when you're talking frequency. If I turn that into a percentage, so let's say I had 20 out of the 50 states, that would be 40%. That would be a relative frequency. So they're both histograms. It just depends on whether you have like numbers or percents running along the vertical. But what you're going to do is the horizontal is going to have a scale. The scale should be equal size bins, so 0, 5, 10, 15, 20, 25. Running along the vertical, your scale should be the same bins, but they don't have to be the same width as the horizontal. So I could actually have made this 0, 2, 4, 6, 8, 10, 12, 14, all the way up to 20 if I had wanted to. But all of them are 2s. All of these are 5s. You could have made these counted by 10s and these by 6s. I mean, it's up to you, but they have to be the same width, or the same bin size. Now, we draw our bars. And our bars are no horizontal space in between unless there's no data there. So let's say we had nothing between 15 to 20% here. Then we wouldn't have a bar there. But in other words, we want to have all those bars together for a histogram. When the bars are separated with some white space, that's a bar graph. Bar graphs are for categorical data. Histograms are for quantitative data. So that's kind of just the way to remember it. So that's our histogram. The final one is called a stem plot. And again, here's a stem plot, and here's how we look at it on a stem plot. A stem plot actually goes ahead, and stem plot will, we will list two sets of numbers, our stems and our leaves. So the way this works out is, if you want to kind of visualize what we're talking about with stems and leaves are, if I was tracking numbers like students' heights in centimeters, 1, 5, 1, 6, 1, 7, 1, 8, these represent the first two digits of students' heights in centimeters. So 1, 5, this little bar 1, would represent a 151 centimeter tall student. 1, 6/5 would be 165. 1, 8/0 would be 180. So that's what we have when we talk about a stem and a leaf. Your stems are typically going to be all but the last number. Your leaves are going to be the numbers. Okay, so that's how I want you to look at it. The way stem and leaves work is it really is, in essence, a histogram. If you were to imagine doing a histogram on its side. So imagine I did a histogram this way, where I counted my numbers down, 0, 5, 10, and then what I'm going to do is going with my leaves off to the side. That's what this is. That's all this is. Because if we actually go ahead and look at this, 15, 16, 17, 18, there we have our numbers running along the bottom, bins of size 1, and then we have more or less the count of them running up. So it's kind of like a histogram, but we actually see a little bit more of the data. So that's a stem plot. A stem plot allows you to look at data, see the shape of the data, and work with it. So hopefully that kind of helps a little bit with a stem plot. I'll close a little bit of the loops on the stem plot when I see you on Friday, but that's what I wanted to kind of finish off the lesson. You should recognize this because we did this in class, but I kind of cleaned it up. And what I wanted to do is, again, review how you describe a distribution. We actually are going to use the acronym CUSC. So we're going to use the acronym CUSSC. The first thing you should always talk about is this S for shape. You're going to describe a shape as either symmetric or skewed. I've added one new one here. I've actually added uniform. What I want you to look at with symmetric versus uniform is actually symmetric. But the thing I notice about with uniform is that all the bars are of roughly the same height. So what that really tells you is you have a uniform distribution when it kind of looks like a rectangle. But that is also symmetric. So you could get away with calling that symmetric. I just want you to know uniform is a description that will come up. So symmetric is one shape. Skewed left, like your left foot, that's your big toe. Skewed right, like your right foot, that's your big toe. Depending on the shape, tells you the center you're going to pick. So if it's symmetric, you're going to use mean for center. If it's skewed, you're going to use median for center. So that's going to lead you down the path. Now, if you use mean for center, you must use standard deviation for your spread or your variability. If you're using median, you should use your range, which is max minus min, or your interquartile range, IQR, which is quartile 3 minus quartile 1. So if you know the shape tells you what center to use. If you pick a center, you know what spread to use. So symmetric, mean, standard deviation, skewed, median, range, or IQR. Hopefully then that's really going to take care of the C's, the S's, and the last C is always context. If you notice, I put, don't forget context. Always put your units of measure down when you do it. Whenever you give me a number, give me a unit of measure with it. The final thing is your unusual features. And we did talk briefly about this. Unusual features are technically your modality, your holes, and your outliers. We talked a little about outliers, but I want to talk about what multimodality looks like. I want to talk to you what holes look like. So if we're working with a distribution and we want to see a distribution with a hole, it's going to look something like this. We're going to have a distribution, and let's say we had a histogram. That right there would be a hole. That's how I would talk to a hole. There's a gap in the data. You'd want to address any holes you see in the data. And I'll say it a lot in class. You'll know a hole when you see it. It's not going to be something really small. It's going to be something relatively noticeable. Now that's a hole. I also want to talk about modality. I'm hoping you remember back what mode means. Mode means the most common number. So imagine I had a graph that looked like this. So in this case, I don't really have a hole per se, but what I actually do is I have what looks like two most common numbers, two modes, the most common numbers. This would be bimodal. Bimodal means more than one mode. So you want to look at this as a bimodal distribution. If you had three modes, it would be trimodal. If anything more, you would call it multimodal. But I will tell you, most often it's bimodal. So that's how you wanted to look in terms of unusual features. So again, your unusual features really are any holes you may find, any multimodality you would find, so more than one mode, and then our outliers. And we'll be talking about this again on Friday, the outliers, making sure we understand how to get the outliers. So that's closing the loop on what we talked about last time. Hopefully that kind of helps. Please reach out to me via email if you have any questions. And I look forward to talking to you on Friday. The way I know that you've actually watched this is if you watch this video, I'm going to ask that you go ahead and do in the previous class, that class we had where we describe a distribution. I'll show you what I mean. I want you to go to our class day 1. So I'll show you, and I'll put this in the instructions as well. I want you to go to this day 3, displaying quantitative data with graphs. I want you to work on this homework. I want you to go ahead and try and see if you can describe this distribution, this stem plot. Using CUSC, talk about the center, talk about the spread, talk about the shape, talk about any unusual features, and always talk about context. So in this case, number of birds. So all your numbers should reference number of birds. Again, email me if you have questions. Thank you.